Okay, so, oh yeah, the course book is the textbook is still totally usable. Like, it's free, it's open source, you can use it. It's awesome. Heck, you could create your own course, although it wouldn't do much for you, right? You could create your own course using it. So let's talk first about the upcoming couple of days. Today, I'm going to go over a tool called Git, and I'm going to talk about the final project and what's coming up in the next days. And I'm going to do that in reverse order. On Thursday, we are going to, it shouldn't. On Thursday, what we're going to do is that I'm going to go into more detail about those final projects and show you some good examples, as well as the different things we can take. I might go into detail into some of the tools you might want to use for that and consider. For the lab this week, there isn't actually going to, the next few labs are going to be basically proposal, intermission, and update on your, intermediate update on the progress of your project, and then when the semester is done, then you've got your final project. Your final project will basically consist of not only the code, but a 2-minute video explaining of the code. So I will teach you how to use OBS as well, because you should learn how to use that. Yes, you can finish work you didn't complete on Windows. What's up, Cameron? Lab this week. Oh, okay. So as far as bad examples, this is the first time I'm doing a final project like this. Okay, so I expect it might be a bit of a crash course for all of us, and that's okay. So my expectations aren't necessarily low, but they're reasonable, especially given the nature of let's see, there's a pandemic going on. People are trying to spoiler, all classes are big guinea pig classes, especially since the idea of education, at least formal education like this one, where we're trying to figure this out, is like not that young. Is pretty young. Computer science in itself, right, really only formally came about in the, about over 50, 60, 70 years ago. So anybody who's telling you we've got this down pat and the correct way to teach it, they're lying. Project-wise, though, I have some good ideas, and we're going to be working off of some stuff here. So, but broadly speaking, I'm going to lay out 3 very well-defined tracks for you that you can use. One for creating video games, one for creating a website/web app, one for creating an app on a phone. They may require you to learn another programming language, but don't worry, that's well within your capabilities at this point. And there are videos already developed for those. Okay. On the more fluid side of things, you could also do some hardware programming using a Raspberry Pi. You could do some, and I'll get into that. But let me just consider. I just need to remember what. Right. So also on Thursday, because it's Halloween, feel free to dress up in costume. I'll dress up in my Luigi costume for Thursday. Okay. And on Tuesday, next Tuesday, we will not be having a, so there won't be a required class because of the election day. I'm a firm believer that that the election day should be a federal holiday. But because it's also the federal election, and because it's not a, and because it is not, a federal holiday, I'm still going to hold class but it will be a special election day class, totally optional. We will be discussing the concept of how districts are drawn in the United States, and the concept of gerrymandering, and looking at, and we'll be writing a program that will help us detect gerrymandering. So, so that's that. So now with regards to what we can expect to do for your projects, so let me go ahead and start sharing my screen. Okay, let's go ahead and start sharing my screen. Oh, okay, I think I'm sharing the wrong screen. Stop share. Right, again, it's all messed up because of the because this. So part of what I'm going to be relying on is the CS50X course from Harvard. So it's not like I'm going into this blind. They have a lot of materials for developing games. So over here, they show how to develop a game they teach you basically how to do games programming by recreating the game Pong and then the game Mario. Each of these has a video associated with it. This is not just 1 week's worth of stuff. This is like for 2 weeks worth of, I think, of material. So each of these expected to be about 2 weeks worth of work. Over here, this web track will teach you how to do HTML, CSS, JavaScript, how to make a homepage, how to use Flask, which is built using Python, how to connect to a database if you want to keep stuff, and then a final exercise. So these are basically nice packaged things to help you teach you how to do something. And I'm going to look into each of these in more detail, probably go through as much of them as possible myself. But these are good tracks to do. These are good starting places as to what to do for a final project. For instance, what they put down for a final project would be you could write a web-based application using JavaScript, Python, and SQL based on the code that you get in there. See, getting a chat. So, oh yes. So Alan asks, would these projects be useful for job resumes? And the answer is expletive yes. So because that's part of the reason I'm going to be teaching you GitHub today. Part of the way that I got my initial Google interviews, and my friend got their initial interviews with Google, were by basically getting our code discovered on GitHub. So, and then a recruiter contacting us that way. So, but let's see, web-based application, creating an iOS app using Swift. So that's the programming language. That and Objective-C are the only languages that you can use to program iOS apps in. So that's why. Using a game with Lua with Love, Lua being a programming language, Love being the framework. An Android app using Java. Android is developed using either Java or Kotlin, I don't know how to pronounce it. But if you know Java or C, then this is definitely a good thing. Creating a Chrome extension or Firefox. Chrome extension using JavaScript, something that's command line based. Hardware-based application for which you use some device. So for instance, you can get Raspberry Pi. I don't know if you know what these are. These are really awesome things. These are small computers, basically computer on a board. Okay, about credit card size computer, about $35 for one. A smaller one is about $5 to $10, like even stripped down version. But there's some other projects over here that you can learn. Notice that they have Python projects over here, right? One of my personal favorite was one that so yeah, the Pi-hole is pretty good. That's basically a big ad blocker for your network. And I shared this on the Discord. I found this one pretty good. I'm going to go and get the link and click on it. Okay, which is, I thought this would be a fun project, which is a laser tripwire. So let me go ahead and actually, I'll need to stop sharing and reshare so I can enable sound. Stop sharing. Share computer sound. Optimize screen for sharing a video clip. This may do horrible things.
The laser pointer gaffer taped to the skirting board. And if we look over here, I've got my Raspberry Pi sitting in its box with the straw sticking out there and the laser pointer shining into that. If you want to make sure that the laser's there, what we can do is we can turn the lights off and then we can blow a little bit of flour We can just about see the laser. There we go. We can turn the lights back on now. And then we can get some unsuspecting person to walk through the laser and set it off. And then when they walk back out again, and we can see whether it works with dogs. Loki, come. Yes.
I may have shown you that video solely because there was a dog in it. So, no, I don't want to open FL Studio. Thank you very much. Exit. Okay, let's go back to the meeting controls. So, chat. You can use anything you want for these programming things. In fact, you'll probably have to learn more for these programming projects. Now that project, now was everybody able to see that project? The good. All right. So had that not already existed, that would have been an A in my book. For it to be an A, if you've copied that project, in order for it to be an A now, you'd want to like do one of those two things that that he suggested on the bottom, such as like sending a tweet at you or a text message to you if it detects the intruder, right? So now it notifies you of an intruder, or taking the picture of the intruder. So those kind of things. And the cool thing about that is that may look overwhelming, but if I open it up again and share screen, this time to enable just for regular screen sharing. Okay, share it. That it goes, okay, here's the things you need. Okay. Here's how you build it. Here's how we use this light detecting thing, this light dependent resistor. Here's how we hook it up. Here's how we make noise. And it's, it's fairly big. So those kind of things, you can look over here and get brainstorm and build on projects other people have suggested. So it's really cool. So there is a good thing. Now, you're not going to be going in blind here, mind you, because there will be basically you're going to have I will be building this over for Thursday's class. I'm just kind of giving you a preview of what we're discussing for Thursday. So there will be, as I'll go into more detail on Thursday, a pre-proposal and a proposal. So basically you've got something where a brainstorming session in lab, and then the actual proposal that you want to do. So now let's go ahead and talk about now let's talk about one of the tools that we're going to want to use for this, which is Git. Now, first off, if you do not have a good terminal, if you're running Windows, you'll probably want to start learning how to use PowerShell. And if you don't have which is included in there, right? It looks like this. But honestly, if you're using Windows 10, go and get this Windows Terminal. Best terminal I've used. It's fantastic. And it integrates with tons of stuff that are really powerful. If you're using a Mac, you're already set to go because it's got a very basic but functional terminal in it. So fortunately with Windows, what I can do is now, because of that, is that I can boot up, let's see, can I boot up an Ubuntu instance here? Yes, I can. So fortunately, so let's talk about operating systems for a second. There's two dominant operating systems, or two dominant families of operating systems in the world. Windows-based computers, which are sometimes called PCs. And then you've got Unix-based computers. Commercially, that means Macs, essentially, those made by Apple. However, that also does include the family of Linux-based devices, such as computers running Ubuntu, Pop! OS, CentOS, Fedora, tons of other stuff. I am a Linux user at heart, but honestly, because of all the audio production I'm doing these days and all the VR playing I'm doing, Windows using a virtual machine for Linux does that for me. So, but the advantage here is that I can emulate what you might see on a, I would be able to go walk through you on the same steps, no matter if you're using a Mac or a PC. So one of the things so this is a command line. This is a terminal, sometimes referred to as a command line. Why would I still use a outdated thing like this? Any suggestions? That wasn't a rhetorical question. Why would I still use this? Because you're different. Yeah, it does look very neat when you use a terminal. Something source code? It's good. You can download stuff. Brian is onto something. It is faster. There's a lot of different things that are built into commands there are basic things that are just built into command that are small command line utilities that are very powerful, such as man gives me the manual for a command. So so WC gives me word count. This tells me how many words a file might have in it, or the ability to concatenate files, to pipe things through, to sort things. There's all sorts of things that are built into a programming language called Bash, which most terminals use, especially in Mac. That is what a command prompt is. I mean, it's just a terminal. So but it's also very easy to just kind of manipulate things. But another reason we still use it is that it is still the quickest way to connect to a computer remotely using SSH. So secure shell, in other words. Your tummy is empty. Your tummy is empty? Annie? Where's Mama? You don't know? I'm going to go and just make sure you get something to eat for a second. So look up SSH for a second. And look up how many computers are using Linux. Or specifically how many web servers use Linux. Annie! What would you like? Would you like some crackers? No! Oh, okay. Mama will make you a sandwich when she gets out, okay? What? Can you make I want something to drink with the sandwich. You want something to drink with the sandwich? Well, I'm going to get all the things ready so that Mama can make the sandwich, okay? Peanut butter? Yep, peanut butter. Okay, can you get me a knife? No, that's okay. It's in the drawer. I got it. Please. Yeah, they are. Okay, peanut butter is on the bread. And let's go ahead and put some jelly on. Jam, jelly, the good stuff. But you are making a sandwich. I decided to just be quicker this way. Mama will get you something to drink with the sandwich. Do you need it cut in half? No, I want to take it and drink it. Okay, Mama will get that for you. So, here we go. A sandwich. Yes, a sandwich. I donate the Queen's Pub sandwich. I donate. I didn't like PB&J for the longest time either. Just felt I found that it took. So I didn't like PB&J for the longest time, but I got used to it. Mama will cut it in half for you. And I did ask if you wanted to cut it in half. He said no. All right. So about I think about half to about 2/3 of all computers on all servers on the internet run a something resembling a LAMP stack, or in other words, they run Linux. So connecting to computers running Linux that aren't running a GUI, often using something like a terminal is your best and only option. So that's how. Learning about the command line is valuable. So you're going to see me using the command line for Git a lot, but you don't have to use the command line. There's a perfectly good thing. So speaking of Linux, let's talk about this guy. Linux is named after this guy, the creator of Linux, Linus Torvalds, right? So Linus Torvalds, Finnish American, he is best known for creating the Linux kernel, which is the kernel for the new Linux operating system. In other words, it's again, one of those Unix-based operating systems, runs the same kind of terminal commands as Mac systems are able to, because those are both based off the Unix system. So and that's part of the reason why Apple is actually very popular for programmers, because Unix-based systems are, well, they're really good for programming. There's a lot of tools that are available for programmers on there, so it's very useful. So let's go ahead now. Linus Torvalds named the Linux kernel after himself, but he also named Git after himself. So he does have a self-deprecating sense of humor here. So Git is what we call a version control system. So Git is an insult, but unless you're in computer science, in which case it's one of the most popular tools for what's called version control. So does anybody here know what version control is? You can unmute yourself and give me the answer if you want to, or type it in the chat. Git, like Google Docs. Kind of. There is a functionality in Google Docs for that, but version control is super powerful. All right. Version control is all about basically saving stuff on steroids. So I'm going to go ahead and grab this laptop, drag it over here, and I'm going to need to use my whiteboard for it. Assuming I put my pen back, which I did not do because I'm upstairs. No, maybe. I had it with me. It was probably in our room. So, I have two computers. Well, sorry. Technically, I have four, but I have 5, 6. Long story. Okay, so I have my primary desktop, which I use. I have my I have this laptop, which I use for lecturing. It's primarily my work laptop. I have my older work laptop, which I got before I went to Japan. I have my laptop from graduate school, which we use for playing on our downstairs TV. We have my wife's desktop, which is connected to our upstairs TV, and then I have a netbook that my friend gave me that I used for very, very interesting. That I have gotten one use out of, and that was was setting up a security camera to track my cat who decided to go into the walls.
Also your old desktop.
Oh yeah, and then there's the old desktop at the school. Yeah, it was kind of the old. You know what? We can give you that story some other time, and I can save that for a different lecture. But it was one of those things where basically I set up the laptop. You can't just say that. All right. So when we first go ahead, can you go and get the laptop from upstairs? The Asus netbook. Yeah, it's on the bookshelf up there. Not that bookshelf, but the because I only realistically use 2. All right. So the yeah, just you can bring the netbook. So what happened with that is that I have this kind of useless laptop from one of my friends. He had no use for it, and I always like picking up any kind of old gear. This is an old 10-inch Asus. I don't know what they're called, but basically they netbooks essentially. It has an Atom processor, which is just so, yeah, it's comparable to that. The biggest thing was the external battery that he added to it. But anyway, so what happened is that we were basically painting our
This was the day we moved.
yeah, this was the day we moved in. You want to tell the story then? Sorry, my wife. So
we didn't paint that room.
they're demanding you tell the story.
Right. Hello. You're in the way.
Yeah, I am in the way. There's the.
Hi. So we have 3 cats and a dog. And when you move an entire house worth of stuff, it takes a long time and the doors are open for a really long time. So we locked them into the smallest room in the house while we took care of everything else. And later in the day, we went in there and we only had 2 cats. So we're like, where did they go? Where is she? And the first time we found her, she was stuffed underneath a dresser that is closed on 3 sides, except for the part that goes against the wall. So we found her. I'm like, okay, that's good. And then we woke up the next morning and we only had 2 cats again. But this time, the part that you can open up to get to the plumbing for the tub had fallen off the wall. And she was not under the dresser where she was before. So we went on a wild goose chase trying to figure out, okay, is she in the kitchen ceiling now? Is she behind the tub? Well, there's that little space, because this is an old house, where she might have gotten above the dining room ceiling, which was a regular ceiling and not a drop ceiling like the kitchen. We had no idea where she was.
This is on the 2nd floor, so.
Yeah. So set up the laptop and saw her coming and going through the hole when we weren't around, because she is a major scaredy cat.
So I can take the programming part of that then. So
Eventually we had to cut a hole in the wall to get her out because she was at the very back of the tub where we could not reach her.
but at
That was
least,
fun.
but we were able to block her from going out of that small
Yes.
thing. So so what I did with this laptop was almost every laptop these days comes equipped with a webcam. It doesn't matter how rubbish it is. It took about a day. It was literally, we got her the next morning. So, so what we did was that we set this up, and I looked for I basically did a bunch of Googling, which says, hey, are there utilities that can turn my webcam into a motion camera detector? The sandwich was yummy. That's good. So the oh, Annie's got the cat in question. So
Notice how much she does not want to be here.
All right. So so what I did was that I figured out basically what required is that, so there is an app or a command line application that requires this to basically take pictures. Now, the big thing with taking pictures is that with motion detection relies off of basically changes in the camera. But if you go and look at your own image on the camera, it's like changing all the time. So you're really looking for a percentage of change, a certain magnitude of change. And so it was just playing around with variables to say, okay, what is a change, okay? And then I basically got it to the correct thing so that it wasn't taking like you know, like 1,000 pictures a second or something ridiculous. So but still able to detect me when I went in and out of the room. So then I flipped it and basically left it on all night. So this is and again, this was a Intel Atom processor. This thing shipped with Windows XP, and it could barely run it at that point. It uses, oh, totally, you could. It's just generally more effort than it's worth. But if you want some kind of project like that, it's not too hard to go from detecting an image to taking an image to then I just took an image, send out a tweet of the image I just saw. So, you know, it's so anyway, would that be a final project? Yes, it would be a final project if that's how to send tweets. I don't know, but there's here, watch. Okay, here's how, let's go ahead and see how to send tweets using Python. Okay. We've got an off course here. How to send tweets with Python. Yeah, it's literally doing this kind of stuff. Tweet using Python. Get started using the Twitter API from Raspberry Pi. So Twitter has an API. Use the API keys with it, and then use the Python module, which basically has all the things you need, which is basically all the libraries you need to and commands you need to be able to send tweets. Okay. It is a lot of programming is just Googling and working on stuff like that. Yeah. So learning how to do, so really a lot of what we've been doing here is teaching you how to teach yourself, because that is a big thing. Now let's talk about Git and GitHub. So what I was talking about was that before we got derailed, but that's okay, was the fact that we were talking about Git is a distributed version control system. So version control system, here we go, has an image. So basically it relies on, so this looks pretty complicated. What this is a image, and I'll move it over here so you're not peering at the side of your screen, is essentially, these are a bunch of basically snapshots of development, okay? Professionally, everything is based off of what's called the trunk. So think of it like a tree. You have a trunk of the tree. And that's the main part of the program. As a beginner, and in fact, for the most part, what I do is mostly just work on the trunk because I'm the only one working on this. But say you're working on some aspect of the program that you need to do. You can create a branch of the program. And a branch basically says, I'm not going to touch the trunk. The trunk works. I don't want to touch it. What I'm going to do over here is I'm going to work off of the branch. This is my own personal copy of the code somewhere else. And then I'm going to make the changes. And then what I'm going to do is that I'm going to merge the changes back into the trunk. Basically, so, right, I start here, I make a change, I make another change, and I merge it back in. A tag essentially is like basically basically putting a nice big, well, tag on your snapshot saying, hey, this is maybe a release. This is version 1.0, okay? That's what a tag typically is. It's like a releasable version. Now, what's cool about this is that, well, let's go ahead and be honest. Who hates group projects, right? I think we're in unanimous consent that basically mandatory group projects that you don't get to decide your own members on are like the worst, right? So, and if you haven't experienced that yet because you're a freshman, let me tell you, they are the worst. Okay, so over here we have a, so basically over here, let's say that that Alice is working on one feature, Bob's working on another feature. This feature doesn't really pan out. So as you can see, the branch got discontinued. They didn't really do anything with it. It just kind of stays out there, not doing that. But Bob's branch, he makes progress on his branch because sometimes what you do is just terrible. And you're like, no, this was a terrible idea. We don't need this feature where it's going to. Bitcoin is actually based off this tree-like structure. Merkle tree, kind of. But yes, Bitcoin does use a similar kind of structure for this, which is based off of hashing previous transactions. And this is what can happen when you get multiple chains of, is what can happen when you have multiple blockchains in Bitcoin. But Bitcoin's designed to basically have one thing, and that's the trunk, which is huge at this point. So, but here we make more changes and merge it in. Now, typically, as a developer, I just typically work on the main trunk. XKCD Git. Now, if you're asking about what professionals do with Git, here we go. This is a summary of it. This is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them into sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. This is like this is, and a lot of us laugh and cry because this describes this describes how we work with Git a lot of the time. So Git does use a wonderful thing called well, it does use a tree-based model, but I'm trying to remember. Why can't I teach it in the other bloody class? Why can't I remember the term? It uses topological sorting to basically figure out what files need to be downloaded and how other things work. But anyway, so Git. So there's a lot of these version control systems out there. Git is by far the most popular, and it's also one of the most recent ones, developed in 2005 by Linus Torvalds. He named it after himself. Again, Git is an insult, so a bit of self-deprecating humor there, which I really appreciate. It's free and open source, and GitHub is the most popular place for basically storing projects using Git. So it's free. Microsoft has acquired it. It's awesome. I still use it. And I would use it even if I was skeptical of Microsoft, because it's just that useful. So now, if you're more of the person who doesn't like Microsoft, there's other companies that use Bitbucket. Oh, sorry, there's Bitbucket. There's a couple of other Git places that you can use, or you can host your own. Right. So so it's really useful. So let's go ahead and take a look at one of my GitHub repositories to kind of give you an idea of what these things look like. So here you can create an account with GitHub. Here we go. And what we're going to look at, because that one is fairly straightforward, and you'll notice I've got like forks over here. Let's go ahead and take a look at, this is my thesis. It just simply has, and I put it on GitHub, has just basically one branch that somebody branched off of. This was a pull request from somebody else who made some changes to some of the files. By the way, take a look at this. It tells you what changed in between stuff. But what's cool about this is that we can like grab. Now I programmed my thesis or rather I wrote my thesis in LaTeX, which is a language like HTML. Okay, so notice I say thesis over here, and it looks like HTML over here. So, and what we can do is that we can basically see that, hey, we can kind of look at these commits and see these histories. A commit is one of those snapshots I told about. And here's basically all the changes I've done over all those years. And I can click on one. almost dying. More data, more trash out. So, right. So as you can see, I was furiously working on this, 3 chapters edited. So over here, we can see how I've edited these things, what's changed over here. And not only that, I can also see like what the exact files were at that point, which is really cool. Now, the great thing about this is that basically, if you like if you code yourself into a corner, like you had it working before, but now the changes you have completely blew everything up and you don't know how to undo everything. Well, if you were committing every so often, you can roll back your changes. So it's a big like save and undo function. And not only that, like you can basically, it enables you to basically work separate from other people and make those changes. So I'm going to so I would suggest creating an account on GitHub. Username, email, and password. Let me go ahead and reload. And what I'll do is I'm going to show you how this works by creating a repository. Okay, a repository is a thing where you store your code. So I'm the owner here, right? It's me with a picture. It's a small picture of me with happy feet. That's my picture there. So repository name, CIS 1051 lecture demo. As a student or an academic, you get like free use of it, which is awesome. It used to be that all things were public, and unless you had an account, which then you could make things private. Sorry, unless you had a paid account, in which case things were private. Now it's become such an important thing, you can have private thing. Public means anybody can see it. You choose who can commit to it. So anybody can see it. You choose who gets the right to it. You by default, but you can add partners to it. And then let's see. Private. You can see that means basically it's hidden. So like this, when I write my exams and stuff, that's all in a private repo. So so what are these files? I'm going to go ahead and initialize with a Readme file. Okay. I'm going to go ahead and initialize with, so a git ignore I won't need. What a git ignore does is that basically it says, hey, these are files that I want Git to ignore. Maybe they're like mid compilation files. Make sense? Like when you're programming with C, it creates object files and then it creates your executable. So it basically, you can basically tell what kind of files or specific files you don't want Git to track in that folder. License. The license tells others what you can and cannot do with your code. Choosealicense.com, very useful about it. If you might be getting deja vu if you're coming in from music software, because they probably talk to you about licensing there. If they don't, they should. But anyway, just be leery if you're working on computers owned by Temple. I'm not sure if there's specific carve-out exclusions for students. By default, I would suggest making it something under like under the MIT license or yeah, I would just keep it simple, the MIT license if you need a license, but we don't really need it. But I'll just simply go ahead and choose one, license MIT, which basically says anybody can do anything they want with the code, and I take no responsibility for what you do with it. Create repository, that simple. Boom. Okay. So boom, has Readme, a license, initial commit, one branch because we're on it. And now last time we did it, we updated it was now. Let me refresh this page and it will say last time we updated this was 14 seconds ago. So pretty cool. So how do I get the code? There's a couple different ways I can do that. I can use HTTPS, SSH. I can clone it using the command line. I could SSH. I can use GitHub repo. I could download this zip file and then change it. I can also make changes over here, but let's go ahead and just show you how to get Git first. Git. There it is, git-sem, and download it. You can it comes up with Windows for me because, of course, I'm on Windows. If you're running Mac OS X, makes sense. And if you're running Linux, fairly straightforward, right? Just simply go sudo, if you're using a Debian-based manager, just apt get install Git, but I assume you already knew that if you were using Linux, right? Not apt get, it's just apt these days. So you can install it. It comes with its own bash shell. Now, again, what I'm going to show you is how to use the command line, because that's what works on for the command line is consistent for every single platform, be it Linux, be it Windows, be it Mac, be it some other, some other licensing, some other programming system that nobody else uses, like Haiku. So what we're going to do over here is, now that we've got it, let's see, where is my, okay, here's the lecture demo. So I'm going to go ahead and just simply say, so there's a desktop app, we can use that. What I'm going to do is I'm going to copy this URL, okay? And then to use it, to get it on my computer, all I do is, here I'm in my home folder. So go to the folder you want to, but by default, you're in the home folder. If you want to go somewhere else, right? Well, if you're on Windows, a Windows machine, first off, by default, where you currently are on your computer when you open a command line is your home folder. So on your home folder, let's go ahead and I will show you where that is. So users, so that would be under operating system. So your primary thing, users, and then your name, which is on this computer Profa. And because it concatenated Professor Rosen, because it concatenated my email. So there we go. And there's a bunch of basically your documents folder, your downloads folder, your music folder, all that stuff. Okay. People still chat. Is anybody typing or have any questions? I haven't seen any activity on chat yet. Am I still connected? Okay, good. Good, I see a no. Okay, so, all right, you start here. If you're on a Linux computer, if you're on a Linux or Unix-based computer, like a Mac, you will probably see something like this over here. This stands for home. This dash, this little tilde over here stands for home. So I can increase the size, I think, but regardless, what we can do, if we say ls over here, this stands for list files. This works in PowerShell and in terminal, but it doesn't work in the command line sorry, it doesn't work in Windows command line. Okay, so ls, that will list anything in here, and there's nothing in here. You can use cd ... to go up a directory. ... means previous directory. And then to change a directory, well, we know that basically there's just the Andrew folder in here, which is my home folder there. So that's how, and this is where it would be on your computer there. Now, so to get it, doesn't matter if you're working in Windows or Mac, we just simply say Git Clone, because we're cloning it onto our computer, and then paste the URL in. Okay. You may have to hit Control-Shift-V. What I love about Windows PowerShell is that it says nobody uses those Control-V commands that were originally set up anymore. So Control-V is just going to paste like it does in a reasonable world. And so we just simply clone this, and we'll get some messages. If it's public, it won't ask you for any authentication or anything. But there we go. And so now if I say ls, we list it, and we see that we've got CIS 1051 lecture demo, and that wasn't there before. And if we check over here, that folder is now here, right? So I'm going to go ahead and CD into it, but there's no need, honestly, to do that. But I'm going to go ahead and CD into it. If you're lazy, though, and you just want to open it up, boom, right? Right-click there. I think Mac has something similar, being able to open a bash shell at a point. If they don't, there's probably an extension to do that. Regardless, let's go ahead and take a look at this README. So README is a .md file. This is MD here is short for Markdown, which is a very basic, like trimmed down. It's an extension of markup, which is supposed to be like a simpler renderer for HTML. It's a very easy way to render things. So like this is big heading, and this is slightly smaller heading. Okay, so I've saved this, made a change to this file, and I've saved it. Now it doesn't automatically update things because this is kind of thing that only should manually happen. Now, if you have the GUI, you can basically just hit a button and it will work. But let's show you how to do it in the command line. So I've just went ahead and changed this README file. So I'm going to say git commit because I say the changes are good. This is what I want to do. And then I can do one of two things. -A is commits and basically marks the saves for all the files I've done. So if I've changed multiple files, this is pretty useful. If on the other hand, you just want to, update one file, you just simply say what file you updated. Tab completion is a great thing. Right there, it just said //. Dot means here. So // in this folder, it's saying the README file. It's just the way that autocomplete works. So here it will say, here is a message. Now it will probably tell you in the command line. Now I'm using VI, which is this whole other ball game there. But anyway, I'm going to type in VI. So I'm in insert mode now. I did that by hitting I. We've made our first change to the file. Escape to X, the README mode, right quit. That was created before Control-C and Control-V were canonical for copy and paste. And saving was the canonical term for saving a file. So the W was for write out to the file. So it's an old program, super powerful. But anyway, we've made that change, and now we can push it to the repository in question. So to do that, we use the git push command. We say git push. This is to update the changes to the trunk. Git push, that's all I need to do. All the commits that we made will be pushed. You don't have to do it after every commit. You can make multiple commits and then push them all at once, and it will push them all there. So there. Now let's go ahead and go to GitHub, refresh. And there, the README file was changed a bit. So let's go ahead and change over here. I'm going to go ahead and add let's go ahead and let's see, I got to show you two things here. The first is, how do I add a file over here? So we're going to go ahead and create a file. Let's just go ahead and create a text document over here. We are going to go ahead and create hello.py, just a basic hello world in Python. Yes. Okay. Another thing, if you're working in Windows, you probably want to probably hit the ribbon over here, hit View, and check this box over here, file name extensions. By default, it's off. So this will enable you to see what extensions file names have. So we've just created a blank Python file. Let's go ahead and edit it with Visual Studio Code. Okay. By the way, if you're using VS Code, notice that it's saying activating extension, right? Try it now, whatever. Okay, install. Okay, but notice over here, it's got like a little squiggly icon over here. You might have to really go into here, and it says main. That wasn't there before. Click on it. Create new branch from. In other words, it has automatic GitHub integration. It can tell. So I haven't really used this, but you can basically do all the GitHub stuff you need to do inside of some IDEs or some development environments. It's really cool. So let's go ahead and create our hello world file. We'll just simply say print hello world. Okay, we'll save it. And again, let's go ahead and make another change. So now here's what we've done here though. We've added a new file. So let's go ahead and open up a terminal again. Okay, and again, you can do this all with a single button click if you've got the GUI, but I wanted to show you how to do this because if you're working remotely, this is sometimes the best way to get code to yourself remotely. So if I try to commit this file, commit hello.py, says it does not match any files known to Git, which kind of tells you something here, right? The Git only cares about files that you told it to care about, okay? So what we're going to do is that we're going to tell Git to care about this file. Git add. So we've got Git, we've got commit. So we've got clone to get started to download stuff. We've got commit to save changes, push to upload our changes, and add to add a new file to care about. Git add, and I actually would have a bunch of like flyers to give you guys if we were actually on campus. Because GitHub sent me a bunch, which is awesome. So git add, and we just add the name of the file. If you're lazy and have a bunch of files to upload, you can just simply do star.py, which means get all the files that end with that. I don't have it with me. They're fairly straightforward to use though. There's here, Git cheat sheet PDF. This is exactly what they give me. This is exactly what I got from them, but basically Google Git cheat sheet. And really these are the command. There's a lot more commands here, but there's only a couple that we use. So I'm only going over the really important ones today. So now that we've committed it, now that we've got it, we can commit it. And now it says, here's the changes. It says new file, hello.py. Give it a meaningful message, which is something you'll find yourself doing less of the more project goes on. And now to upload it, we say git push. Now, what's I find really useful is that this is how I synchronize my code between two computers a lot of the time. So let's pretend we're working on another computer. Really, I'm working in the web browser over here, but this is how I would work on a new computer, how I would do something over here. So let's say I'm working on a new computer. Okay, and I create a new file called, let's call it add.py. Oh, actually, I didn't want a folder. Add.py. Okay, and all I'm going to do is say def add is equal to def add xy return x plus y. That's all it is. So here I've said create this, and I'm going to go ahead and create this. Basically, pretend what I've done is I've just created a new file on another computer, okay? And I've pushed it over here. Well, now my computer, one of my projects is out of sync. That's perfectly fine. I could work on it, but let's show you how to get back in sync. Well, we pushed to upload. So you can probably guess what the command is to download any changes that have been made. Okay, yep. Just and here the caveat again for all these Git commands to work is that you got to be inside the folder. Git pull. Again, another thing you could do if you have the GUI app, you can just hit a button and it works. Right, so pull. We'll change that and then we can make our changes. So now let's go ahead, and what I'm going to show you is what happens if you have changes one place and changes somewhere else. So here I'm going to go ahead and edit this. Notice there's a blame button. That's something I'm not too much. Notice it also supports syntax highlighting. adds to numbers. Okay, so I'm adding a comment over here, commit changes, upload. So I've uploaded them from this computer and I pushed them to over here. Okay, so now let's go back to my computer over here. I'm working on a separate file over here. I'm working on the hello file. Okay, don't really care about that py file. So let's, okay. Yeah, the profile, yeah, that's not as long as my hair's gotten. My hair's gotten longer. So let's go ahead and comment this. So we've modified the file, and nothing stops me from making multiple commits here, right? So I could, so I'm just going to change the file. Added a comment. So now, so let's go ahead and just give you a refresher of what I just did here, right? So, right, I've made the changes over here to add, right? Made a change to add over here on, and then I've uploaded it to the GitHub website. That's what we're pretending we did. And then on the computer over here, my laptop, what I've done is that I've made changes to the hello file, right? So we've got one change over here and another change over here, mean simultaneously. How do we deal with this? Well, if it's easy, actually the computer will deal with it for us, but we'll just encounter an error first. Git push. So somebody already pushed before us. So I try to push, and here's what happens. It says it failed to push, and it was rejected. Hint, updates were rejected because the remote contains work you do not have locally. This is usually caused by another repository pushing to the same ref. You may want to integrate the remote changes first before pushing again. So what we do fine, git pull. So I git pull again, and watch what happens. Unpacking, remote, unpacking, merge made by the recursive strategy. So in other words, it detected the changes and it merged my work with the other work. So git commit. So I'm going to make another commit here. Just going to type git commit. Nothing to work. Tree's clean. And now my branch is ahead by 2 commits, it's saying. Because it automatically did another commit where it made the change to merge my 2 separate branches together. My 2 separate things together. So now we have add with the add to numbers comment and hello over here in the same thing. And so now I can go ahead and push. So it automatically integrated it. So now git push. And now let's look at the comments that we have over here. F5. And there are the changes that we made. Now notice that it doesn't say that we did, that's when we made the commit, not necessarily when we uploaded it. The last comment though was merge of these main things. So it's pretty useful. Again, this can be automatically sorted out by just hitting a button if you're using the GUI. But worst case scenario, you might have something that happens like this, okay? Commit changes over here, upload. And this is where it gets messy, but this is as messy as it gets. And this is where the comic says, no idea, just if you have issues, save your work elsewhere, delete the project and download a fresh copy. Where this is where that might happen, which is no problem whatsoever, which is actually fairly easy to get around. So now let's go ahead and modify this add method. So instead of doing X and Y, I'm going to do Y and Z, Y and Z, right? So notice that over here, what I've done with the add was I changed it to A and B, and over here I changed it to Y and Z. So git commit, made variable names more awesome. Total lie, but hey, should always be selling your code. So, okay, so now we've done that. Now let's go ahead and try to push, right? Which will get rejected the same way we did because we've already have commits that we didn't get first. So, okay, git pull. And now you'll see that it says it unpacked it and it says auto merging fail. Merge conflicts in add.py, fix the conflicts, and then commit the result. Okay, notice it gave you directions. It says the merge failed, fix the conflicts, then, okay, what are the conflicts? Well, let's open it up. And it turns out, look at this. It's already, that basically it's already changed in here. Okay. And by the way, notice that there's some stuff over here, accept current change, accept income. This is what I mean, like Visual Studio Code has GitHub integration. But basically, we've got our head change over here. So when it's got changes like this, it has all these symbols which say, hey, this is what you have. This is whatever you just pulled has. Which one do you want to keep, or do you want to change them, or what? I like the incoming change more. So I will just simply fix the file by just simply deleting all the extraneous stuff, or I can just hit this button over here. Save. Git commit. Merge of those two branches. So it automatically has the common for me, git push. So that really only happens though if you aren't careful about updating your stuff or you're working with other people. But again, it's not too much of a headache to resolve. And again, what we can do also with this is that we've got snapshots of our code all throughout this. So we can see all the changes we've made to these things, which is great. So, so that's pretty awesome. Now, again, GitHub is free. I highly recommend you use GitHub or some other. In fact, I'll probably require that you use GitHub or something else to host your project source code. Okay. Not necessarily GitHub. If you don't like GitHub, whatever. Don't care. That's fine. But if you want to host it on Bitbucket or something else, then I just want your code to be there and be able to, and so we can see the changes as it happens. Now let's talk about GUI. So windows.github.com, right? Here's a GUI. And again, really all you need to do is just hit a button and it works. Notice that I typed in Windows, but it brought me to desktop. Same thing will happen if you type Mac, I bet, which it will show and here. So here it says, hey, download for Mac OS X if you need it. And so there you go. So this, you just would simply, and this is part of the reason why GitHub is so popular. It makes this process, this command line process, very easy to use. All you have to do is put in your credentials, which hopefully you would make complete unique, right? And all you have to do to create an account is, I'll go ahead and just kind of show you by logging out in the last couple minutes here. So sign out. Username. Let's go with Prof. Rosen Demo. And what I'm going to use is TUG85861@temple.edu, right? Using that. I'm going to go ahead and use a securely generated random password for this website. Sign up for GitHub. Save that. It wants me to verify my account, probably by, okay, solve the puzzle. Pick the spiral galaxy. Boom. Okay, cool. And then join a free plan. And then say that I am a student because I'm pretending to be a student. Let's go ahead and say a little. Learn to code, host a project. You can create a website with those. And see. So I would select these probably. host a project, and then complete setup. You'll be able to, and then I will be able to verify that, and you'll be able to get started with it. So this recording, right? If we go to Canvas, so I'll upload this basically ASAP. But well, the way you get to this recording again, go to our Python web course. Go to grades, not grades. Go to here, lecture recordings, right in the middle. And it will have a YouTube playlist of all the lectures that we've done. And I'll just simply add it to this to the end of this playlist. Okay. So that is Git in a nutshell. Now, I want to emphasize why you should use this. Not only does this help with the whole, like, oh no, I was storing my dissertation on a USB flash drive, and now I lost it, or dropped it in a puddle, and now I've lost 5 years of my work, kind of deal. Or, you know, my computer, I can't use my computer because the electrical socket that it's plugged into is dead. And so now I'm working on my laptop. But that's no worries, because all my code is hosted in the cloud, which is shorthand for somebody else's computer. And so all I have to do is pull it from the cloud and install it on my computer. This also allows me to contribute code there, or rather synchronize my code between them. But finally, another big reason we would do this is because it's a great way to host portfolios. GitHub is basically one of those places where you can put a portfolio of that code in. So let me leave you in our last minute with some other ideas about 2 more ideas I've had about what you might want to do. Now, I did have a question about what you could do with turtles. You could see about doing a simulation with turtles. So creating some kind of simulation. One of the more classic simulations is traffic simulation, where basically we see how a single vehicle slowing down creates traffic just by having turtles try to make sure they don't crash into each other. And all they do is just kind of go around in a circle, and then occasionally one slows down, and it causes the other ones to slow down. And then it starts back up again. It just kind of creates that phantom traffic. So that kind of simulation kind of help those kind of things. So you can modify those things and see how that works. If you want to use that. So I will help you get started with these things, but we will work, but I will have more details for you all on Thursday for these. Okay.